Hello and welcome to Software Architecture course. We will continue with design patterns. So in this lecture, we will study the structural design pattern. In the previous lecture, we covered creational design patterns. In this lecture, we will consider a set of design patterns that are important for structure. So what is exactly a structural design pattern? Basically, structural pattern is a set of design patterns which provides an easy and generalized way to implement various relationship between classes. When you are building a complex application consists of many classes, and these classes interact with each other as well as they are related to each other. So structural pattern is essentially about defining those relationships in a more generalized manner. It's not very tightly coupled again. Just like we learned in creational pattern, we will also learn here how one can make those structural relationships more generalized so that it is possible to add, modify elements easily. So as a part of structural pattern, we are going to study four important design patterns: the decorator pattern, the adapter pattern, composite pattern, and proxy pattern. So let's start with the decorator pattern. What is a decorator pattern? So the requirement is that a component object need to be enhanced. For example, I have a component window, a GUI component window, and I would like to add a scroll bar to it. So my window, that object that I had, did not have a scroll bar. I want to add a scroll bar. So that is basically one requirement. Or there could be additional responsibilities that I may want to add. So another requirement is that the decorated object, meaning that in this example the window with a scroll bar, can be used in the same way as the undecorated object, meaning that wherever I was using a window, instead of a simple window, I should be able to use a window with a scroll bar. So I can always replace the window with a scroll bar window. So I can actually use new decorated objects. Now the original component, meaning the original designer of window, really would not like to take any responsibility for the decoration, for the simple reason that if the original designer takes the responsibility of adding new features, then the original design will never be closed. It will always be open for change, and that can create problems. So here the whole purpose is that I should be able to extend it. I should not touch the original design. I should extend it and add new responsibilities to the extended design. Now there could be many such possible decorations which at any given point of time the designer would not know. So such requirements come later, and when these requirements come later, it should be possible to add those additional features to the existing class without hampering, modifying the existing design. So that's very important, that existing design should be left untouched as much as possible. I should be able to just add additional feature to the existing class. That's what is the decorator pattern. Let's look at an example. So this is a class diagram on the right hand side, and this example is about window component. So let's see that there is, so if you observe, the window component is basically an interface. That interface has two methods called a render window and close window. So a class called simple window basically implements the window component, and this simple window implements the facility like rendering window or closing window. And there is something called a window decorator class, which is of relevance to us. So this window decorator is essentially a window because it realizes the window component, but it has some additional features, has its additional characteristics which we will study more carefully. Because window decorator itself is a window, so therefore this window decorator should also implement methods like render window as well as close window. But please note that there is a aggregation relationship, okay, with window component. This is the key. This is the important relationship. This is what makes it a decorator. And now one can have different types of window decorator. For example, scrollable window could be one decorator, auto adjustable window could be another decorator. So these two are two different types of decorators. Now, important part is that this window decorator, or even scrollable window decorator or auto adjustable window, they all add additional feature on top of this simple window. We will see how. So the first step is to define an interface. That's an abstraction for the component. Then the concrete component classes basically realize this interface type. That's the next step. Like simple window is a concrete component. Decorator class also realizes the same interface, like window decorator here. Now, decorator object basically manages the component object that it decorates. Very important. That's why I require this aggregation relationship. So this window reference, this is basically the component object that this decorator manages and also decorates. So if you look at the creator method or the constructor here, window decorator constructor. So window decorator constructor takes a parameter which is W of type window component. So this is the window component W that window decorator basically manages as well as decorates. So when implementing a method from the component interface type like window component, the decorator class, what it does, it first calls the method on the decorated component, meaning that this render window will call this, and then on top of that it will add additional functionality, and then it combines the result with the effect of the decoration. So the way it works is, in summary, is that the window decorator, basically a lightweight decorator object on this main simple window concrete class. When window decorator is created, it takes an argument which is of type window component. One can supply, for example, a simple window as a parameter here. Now this decorator is going to manage this simple window, plus it will add additional functionality. So when a render window is going to be called on the decorator window, this render window, inside it will first call the render window method of this simple window. Then it will add additional functionality. That's a basic idea. That's how the decorator pattern extends the functionality. So let's see how a decorator can be used. So here is my GUI application. This is the client, and this is again a Java program. So inside the main method, what I'm doing is that window W is new concrete window. I can call w.render window. Then sometime later, suppose I want to add additional feature to this window. So what I do is that W, the same W, is a new scrollable window. This scrollable window is basically the decorator, and I pass the parameter W here. So this W was this simple or concrete window. So I pass this here, and then this becomes a decorated window, this W. And then when I call w.render window, then this W will have additional behavior, not just the behavior which was there here, but also additional behavior with respect to the scrollable window. So the GUI main function uses the decorator pattern by first creating a decorated object, which is scrollable window, as I said, and then invokes the main method window w.render window, which is defined as an interface, and this render window first calls the concrete windows render window method, and then it calls the additional functionality. Let us look at its usage in JDK. And actually in JDK, if you observe it carefully, you will find that decorator pattern is heavily used, at least in file IO package, very heavily used. Example is reader. A reader is actually an interface, and a buffered reader is a decorator. So the way it can be used is, for example, reader r equal to new buffered reader. Then as this new buffered reader is created, which is a decorated object, you are passing a parameter which is new file reader. So file reader is essentially a concrete reader class, and buffered reader is a decorator class. So buffer reader takes the component file reader into it, and then it adds additional functionality, which is basically buffering the read operation. File reader does not have the buffering mechanism, but buffered reader has the buffering mechanism. And then when you call r.read on the reader, the buffered reader will first call file reader's read method, and then it will add the additional buffering capability. So let's look at various consequences. Now decoration is essentially more convenient mechanism for adding functionalities to objects instead of entire class at runtime. So using this, you can add functionality, as you can see in this example of file IO, that on top of file reader at runtime you are adding a buffering capability. Now file reader obviously does not have buffering capability, but you are adding it at runtime. With decoration, it's also possible to remove the added functionalities completely. That's also possible, which is a negative decoration. You are not adding, but you are basically subtracting or removing certain features. That's also possible. Now decoration has its own problem. So decoration is a more roundabout way of adding functionality, additional functionality at runtime. So that makes the whole debugging of the functionality quite difficult. It's not very straightforward to understand and debug when there is a problem because of this indirection. With this we conclude. We'll continue with other design patterns in the next class.